Hello and welcome. Today I will be talking about the paper called Towards Alzheimer's Disease Classification Through Transfer Learning. The outline today is, first, what is Alzheimer's, followed by what is CNN, which is a convolutional neural network, what is entropy, what is ImageNet, what is transfer learning, what are VGG16 and InceptionV4, and our results. So first, what is Alzheimer's? So Alzheimer's, also known as AD, is a neurodegenerative disease causing dementia in elderly population. It is predicted that 1 out of every 85 people will be affected by Alzheimer's by 2050. Now, early diagnosis is possible through analysis of MRI images and also with machine learning. Now, the question is, what is normal memory loss and what is Alzheimer's? So with normal memory loss, you forget something, you know you forgot something. And with Alzheimer's, you forget something and you don't realize you forgot anything. So visually looking at the MRI pictures, we can clearly tell if somebody has Alzheimer's or not. Here on the left, image A, this is a healthy patient. And image B, it is a patient with Alzheimer's. We can see that in the center, which holds the hippocampus, which is the organ for memory, in the normal person, it is intact. Whereas in the person with Alzheimer's, we can see that there's holes, which means that there's less hippocampus available. Now, in this project, what we're going to do is we're going to use convolutional neural network in order to be able to predict if an image is Alzheimer's or normal. And why is this important? Well, normally what happens is that you have a radiologist that will look at the image and make a prediction, make a statement. Is it Alzheimer's or not? And that is very time consuming and also can have lots of errors. So the goal of this project is to do this analysis automatically with machine learning. So here the tool that we use is the CNN, which is the convolutional neural network. Basically what happens is that we have an image, an input. We use a kernel, which is a small window, and we multiply this kernel across the whole image. Okay, we do this several times. Okay, this is called the convolution. So we take the image, we multiply with a kernel. Okay, and then what happens is that it goes through a ReLU, which means just changing the shape, and then it goes through pooling, which is making the image smaller. Okay, so this is done in several layers of convolution. Okay. Finally, we reach the flattened layer, and then from there we have regular classification, which is regular neural networks. And at the end, we will output what percentage we think the image is. So what does the convolution do? Okay, essentially what the convolution does is that it looks at the image and it's able to extract edges, circles, dark spots. And an image here we have of a zebra. There are certain characteristics of a zebra that really define a zebra. So for example, if you have like a long line at the end of the image, that corresponds to a tail. If you have a front that has like a shape of a triangle, that represents the face of a horse. So what convolutional neural network does is that it breaks the image down into its fundamentals, and from there it is able to piece together what the image probably is. So now we have lots of Alzheimer's and normal people images, but it's very inefficient to just select them at random or select all of them, because there could be some that have more information than others. And this is where entropy comes in. So entropy was developed by Shannon, and he was working with communications and figuring out how much information can be sent over a line. Basically we use this formula here called the entropy formula, and this formula will give a value to say how much information the image possesses. Okay, and when we say information, that means how much distinct features it has that makes it stand out, so to speak. What happens is that in our project we are taking neural networks that have won the ImageNet competition. So what ImageNet is that it was developed, I believe it was by Stanford, And they basically, what they did is they collected thousands of images of thousands of categories and gave a challenge called the ImageNet Large Scale Visual Recognition Challenge. And year after year, people were trying to create models that that were able to predict images. And in specific, I want to highlight InceptionV4 and VGG16. So InceptionV4 was able to do with quite a relatively small amount of operations, and it has a top accuracy. Here it's like 80%. VGG16 also pretty low operations and quite a high percentage accuracy of 70%. Now, another topic that's important to learn is called transfer learning. And this is what happens, that you have a system. Okay, here we see the top image. The neural network is trained on the ImageNet dataset. Okay, so it's trained on a lot of images, cats and dogs, boats and cars. Okay. What is done later is that we take that neural network after it was trained on the ImageNet. We take that neural network and then we retrain it on our medical dataset. So in our case, with Alzheimer's disease. Okay. So conceptually, what this looks like is, it's like a child, right? First, a child learns shapes, and then eventually they learn how to recognize cars, faces, animals. So you can visualize transfer learning in this respect as well. And the benefit of transfer learning is that you can train here the medical data set much faster, because you don't have to do it from scratch. You're doing it based on already trained. And the other thing that's important to notice is that not only is it faster to train, but it turns out that the accuracy also improves as well, as we'll see in the results. So VGG16 and InceptionV4, these are just two different types of convolutional neural networks. So like I said before, convolutional network consists of convolution neural network plus ReLU plus max pooling. And basically these are done in different combinations. So here we have the VGG16 combination and InceptionV4 combination. And we can see that as time progresses and as our computing powers improve, these CNNs that beat the ImageNet competition, they end up becoming larger and larger and larger. As we can see here, VGG16 is relatively quite small compared to InceptionV4. So here are results. When we did VGG16 trained from scratch with Alzheimer's information, we got an average of accuracy of 74%. When we used transfer learning, which was using ImageNet trained VGG16 model and then retraining it using Alzheimer's, got a better result of 92% average. Then we did InceptionV4 and we got an even better result of 96% average. Now, we also compared our results to some of the results from papers. For example, WaveNet and Neural Network got 90% accuracy with 3,000 training sets. And we can see here that InceptionV4 did very, very well at 96% average, just below the Deep AD Inception at 98% average. But we can see our result is much better. With Deep AD, they had to require 46,000 sample images, whereas here we only use 5,000. Thank you very much. This is the end of our presentation. I hope you enjoyed.